ceria, 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 ceria duniaku. Ceria.
So stressful, so confusing. Why is this?
Why? So stressful.
I'm studying about this Spectro Photometer. So why is this?
Oh, Spectro Photometer.
Yeah.
Easy lah. Let me explain to you.
Spectrophotometer is a device that precisely measures electromagnetic energy at specific wavelengths of light. It uses the characteristics of light and energy to identify colors and determine how much of each color is present in a ray of light. Just like all other tools, this device has its own benefits and drawbacks. Some of the benefits are: it quantifies a qualitative characteristic. For example, the color red might be different for different individuals. However, if the color was obtained by using precise scientific method, there can be no argument, thus easing the communication and discussion of a topic. Other than that, it also offers fast operation, as the result can be obtained in a span of a few seconds, and some models also designed for mass production. However, there are a few setbacks may be experienced by using this device. Number 1, it has somewhat a steep learning curve, which means a proper training should be conducted before a person can fully understand the data and operate the device. Also, not every sample is measurable by a single spectrophotometer. You will need a model that's configured to your needs.
Oh.
Do you understand?
Yeah, but how does it really work?
I'm not sure about that, but I have one very intelligent friend.
Oh, really?
Very smart one.
Yeah.
Yeah, so
Let's
go ask him.
Okay, go.
Okay, let's go. Wise! Wise! What? We need your help.
See, I already lose my game.
Oh, never mind then. Actually, we right now are struggling about this irritating device. You know,
Spectro Photometer.
Yeah, photo spectrometer.
You don't even know that?
But we know what the device is.
Yeah.
But we don't know how does it work. Can you help us?
Wait, I remember I take a note about this. I think it's here.
Yeah.
So the basic way a spectrophotometer function is based on the absorption of photon. The lamp provides the source of light, and the beam of light strike the diffraction grating, which work like a prism and separate the light into its component wavelength. We talk here about the spectrum of energy, where different energy levels create different color. That's why we call it spectro. It refers to the fact that light is dispersed into individual or groups of wavelength in electromagnetic spectrum of energy. As we can see here, the grating is rotated so that only a specific wavelength of light reaches the exit slit. Then the light interact with the sample, and from this point, the detector measures the transmittance and absorbance of the sample. Transmittance refers to the amount of light that pass completely through the sample and strike the detector, while absorbance is the measurement of light that is absorbed by the sample. That's how we call it photometer. It's refer to the ability to measure the intensity of the light at each group of wavelength. Finally, the detector sends the light being transmitted through the sample and convert it into a digital display.
So that's all I know about this. Does it help you?
Yes, it really helps me. But anyhow, how does the machine calculate the absorbance and the transmittance?
Oh, about that, I don't really know about this. But I think Professor Fasanga somehow know about this, I think.
Professor Pasanga,
You know Professor Fasanga?
yeah, he's really famous.
So I think we can ask him.
Sure.
Do you have time now?
Yes.
We can go to his lab.
To his lab. Right now.
Right now.
Okay, let's go.
Assalamualaikum, doktor.
Doctor? Oh, doctor. Are you there?
Oh!
Mama kami sudah pulang, mana janjinya? Jujur ada yang enak. Anak-anakku yang pintar ini mama buatkan. Jujur ada yang enak. Jujur ada kesukaan kami. Enak dinikmati sepanjang hari.
Cucu adabi, kesukaan keluarga, sesuai dinikmati di segala suasana.
Adabi.
How many questions you want to ask me? 1, 2, 3.
Kind of few questions. So are you free right now?
You wait there at my lab. Later I come and
Okay.
I will show you.
Doctor, where are you?
Where are you, doctor?
Where is this old man?
So, what you want to ask me?
Actually, we are studying about Spectro Photometer. So now three of us are confused about how to calculate the absorbance and the transmittance. Can you solve our problem?
About spectrophotometer, easy one. I can help you, but you must look at the art.
As we know, all molecules absorb and emit light differently based on what kind of covalent bonds are in the molecule. Spectrophotometer will give us data in the form of an absorption spectrum, which displays how much light through a band of frequencies is able to pass through a sample to reach the detector. Where there are peaks, it means that not as much of the light of that wavelength is getting to the detector that is being absorbed by the sample. If we collect data like this continuously over the duration of a chemical reaction, we can gather information about how rapidly the absorbance change, and thus how the concentration of a particular substance is changing over time. In order to do this, we will use an equation that relates the amount of material in the sample to the absorption of light passing through it, and this is called Beer's law. Here, A is for absorbance. This symbol represents molar absorptivity, measure of how well a compound absorbs a given wavelength of light. B represents path length. Distance light has to travel through the sample, which is relevant because the more of a substance the light travels through, the more of it that will be absorbed. And C is the concentration of the sample, which again is relevant because the more concentrated, the more absorbance that will occur. Absorbance is measured by comparing the intensity of the beam of light as it enters the sample and the intensity as it leaves the sample and strike the detector, which are I0 and I respectively. and A is equal to log of I0 over I. If we plug the latter version into the original equation, we can get this version of law that are easily measurable. So, we can just let a reaction occur normally and measure the rate indirectly by analyzing the light that interacts with the component in solution, rather than stopping the reaction and measuring concentrations directly. Gathering this kind of information regarding concentration and plotting in real time using computer software will allow us to easily infer all kinds of things about the rate law and hence the reaction mechanism for the reaction that is happening in solution, which is very useful data.
So you understand what I'm talking about?
Yes, doctor, we are really understand. So finally, I am fully understand about the whole thing about spectrophotometer. Maybe it's kinda confusing, but if we go through about it a little, maybe we can understand.
Okay.
So can we dismiss now? Thank you, doctor. So, in conclusion, the future of spectrophotometry lies especially in the improvement of pathological diagnostic, disease detections, and etc. So, spectrophotometer is one of the most useful devices of quantitative analysis in various fields such as physics, chemistry, biochemistry, material, and chemical engineering. Yes, finally. Isham, boys.
Yes, what?
Thank you guys for having me. I just did it.
You understand?
Yeah.
Good job.
So better.
How about me?
Doktor!